following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
Fruit snack only at the shopping center. Love, Mom. P.S. You have mail. Finally, my entry form for the contest. You must correctly answer all 3 questions and the bonus question in order to win the $50 first prize. I'll get started right away, so I'll have my entry form in early. Let me see. Sarah rushed home from school so she could get some of the pie her mom had baked the night before, but she found that her brother Bob had beat her to it. Mom had cut the pie into fifths. Bob was eating his second slice. If Sarah eats 1 slice, what is the total amount of pie the kids ate? Oh, that's easy. All I have to do is add the fractions together. The pie was cut into 5 pieces. That's fifths. So I'll just write out the numbers as fractions. Bob had 2 pieces. That's 2 fifths. And Sarah had 1 piece. That's 1 fifth. 2 plus 1 is 3, and 5 plus 5 is 10. So that's 3/10 of the 3/10, but I thought the pie was cut into fifths. Uh-oh, there's something wrong. I better slow down. Now, if I had a pie, it might look like this. One, 2, 3, 4, 5. Okay, Bob had these 2 pieces, and Sarah had this one. 1, 2, 3 fifths, not tenths. The kids ate 3 fifths of the pie. That's got to be right.
Robert almost lost the contest on the first question. That's because he was trying to work with fractions in the same way he might work with whole numbers. Any fraction can be understood if you just remember that the denominator, the number below the line, tells you how many equal-sized parts something has been divided into. Like this example. These are whole apples, 3 of them. If I add 2 more to the group, then I have 5 whole apples, right? But now look at this. This is 1 whole apple which has been cut into 5 equal-sized pieces. So these 2 slices would represent 2 fifths of the whole apple. This is how you'd write the fraction. 2 fifths, or 2 fifths. The 2 represents 2 of the 5 equal pieces of the whole apple we're dealing with, and is called the numerator. And the 5 represents the denominator, or how many equal-sized parts the apple has been divided into. Now let's think about what we would do if we wanted to add 2 fifths to 1 fifth. How would we go about it? Because the denominators are the same, we can write the problem like this. It helps you to understand what you're doing when you add fractions with like denominators. The word fifths lets us know we're working with the same kinds of things, and we just add 2 plus 1 and get 3 fifths. Now, if we write this problem using numbers, see what happens. We're adding fifths, so 2 plus 1 is 3 fifths. Notice that the denominator stayed the same because they tell what we're adding. Now let's see how Robert's competition is doing with the next fraction problem in the contest.
This is a 2-part problem. First try part 1, then try part 2. Be careful. Part 1. On Sunday morning, Mom made 6 1/4 waffles. Jane eats 2 1/4 waffles, and her brother Bob eats 3 2/4 waffles. How many waffles did the kids eat? Express your answer as a fraction. First thing I'll do is write out the numbers so I can add them. 2 1/4 plus 3 2/4. I think I should add the fractions first. Or am I supposed to add the whole numbers first? Hello? Oh, hi, Robert.
Do you remember if you're supposed to add the whole numbers first or the fractions first when adding mixed numbers?
Hey!
After discovering that they're both unsure about adding and subtracting mixed numbers, Jennifer and Robert agreed to work together on the contest and share the prize.
And have you read part 2?
Well, I think we should add the whole numbers first.
But wait, Jennifer, if these were all whole numbers, we'd add the ones column first, wouldn't we? See, if these were all whole numbers instead of fractions, we'd know exactly what to do.
Oh, okay. Well, since the denominators are the same, let's just add the numerators.
That's simple. 1/4 plus 2/4 equals...
3/4.
And 2 plus 3 is 5.
So the answer to the first part is 5 3/4.
Now we can tackle part 2. How many waffles were left after the kids ate? Show the steps you take in finding your answer.
So all we have to do is...
But wait, there's more. Don't forget you'll have to do some renaming to get the correct answer.
And that's the tricky part.
While the kids think about how to do the renaming, let's take a look at how fractions are used in some tasty ways.
When creating new products, fractions are very important. We're going to experiment with peanut butter in a chocolate chip cookie recipe. I have 6 ingredients. I will put 1/4 teaspoon peanut butter into the first container, a 1/2 teaspoon of peanut butter into the second container, a whole teaspoon of peanut butter into the third container, and then we will keep track of which container, which batch has which amount of peanut butter in it. Maybe the old recipe isn't so bad after all.
Hey, we've got a waffle iron right here. Maybe if we look at it, we'll get some ideas.
Yeah, but that's only one waffle iron. What do we use for waffles?
One paper waffle at your service.
Hey, that's neat. Let me do one.
So this stands for the 6 1/4 waffles their mother made. Now we can take away 5 from the whole waffles. 1, 2, 3, 4, 5. And the kids ate 3/4 of a waffle. I'll just cut out the 1/4 that wasn't eaten.
And I'll add that to this 1/4, which gives us the answer, 2/4 of a waffle.
We've solved the second part. We're gonna win.
Uh-oh.
What's the matter? We have the right answer.
Remember this part? Show the steps you take in finding your answer.
We didn't do that.
Which means we lose the contest if we don't get our work on paper.
But how can you possibly subtract 3/4 from 1/4?
Once upon a time, there was a very rich merchant who lived next door to a very poor pie man. The merchant sold expensive fabrics like silks and satins, which came in odd lengths like 3 3/4 fritters. This meant that he was always having to work with fractions, which made him think that he must be very good at math. Much better than his poor neighbor, the pie man, who just had to sell pies and cakes.
You don't need to know any more to do your job. But look what I have to do. When Lord Toffeenose comes to buy 1 1/4 fritters of silk, and I have 3 3/4 fritters in stock, to find out how much silk I'll have left, I first subtract the top number of 1/4 from the top number of 3/4 to get 2/4. And then I subtract the whole number 1 from the whole number 3 to get my answer, which is 2 2/4.
It was all very clever stuff, and it made the merchant feel more and more pleased with himself, and the poor pie man feel more and more of a loser. Until one day, Lady La-di-da came to buy 1 3/4 fritters of velvet, and all the merchant had in stock was 2 1/4 fritters. To find out how much velvet he'd have left, the merchant started to go through his usual routine.
First, I take the top number of 3/4 from the top number of 1/4, then... Whoops. Wait a minute. I can't take 3 from 1. I'm sorry, your ladyship, but I can't sell you any velvet today because I can't subtract 1 3/4 from 2 1/4. Oh, this is terrible.
Excuse me, but perhaps I could help.
You? What do you know about fractions?
Not much, but I do know about pies. Let's pretend fritters are pies. You have 2 1/4 pies. Lady La-di-da wants to buy 1 3/4 pies. You can't take 3/4 from 1/4, it's true, but you can make use of one of your whole pies. After all, you get 1/4 of a pie by slicing up a whole pie into fourths. So you can think of a whole pie as 4/4.
So what?
So, if you add the 4/4 of one of your whole pies to the 1/4 of a pie, you now have 1 5/4 pies. And you can take 3/4 from 5/4. The answer is 2/4. Then you take one whole number from one whole number. So you'll have 2/4 left. 2/4 of a pie or 2/4 fritters of velvet.
Thank you very much. That's very clever.
Oh, it's not clever. It's as easy as pie.
A lot of good these things did.
But we can't give up yet. There's $50 at stake here.
Robert, you're supposed to wake me up when you got home. Hi, Jennifer.
I'm sorry, I forgot.
Hey, it wouldn't be cheating if we asked him to help us, would it?
Hey, George, do you think you could help us with this math problem?
Look, I'm already late. Paul's here to pick me up for work, and I can't keep him waiting. Sorry.
Please. And I won't tell Mom about what happened last Wednesday.
She already knows, Robert. But I'll help you, so you'll owe me one. What's the problem?
We have to subtract 5 3/4 from 6 1/4, and it can't be done.
Well, it tells you right there it has something to do with renaming.
Yeah, but we can't remember how to do that.
How could you write 1 as a number of fourths? Oh, come on, you guys think. How many fourths equals 1 whole?
4.
This should be able to help you out.
But how? 4/4 and 1 whole are just 2 ways of saying the same thing.
There's Paul. Gotta go.
But how's that going to help us with the subtraction?
What you want to do is change the numerator of the fraction in a larger number. The numerator you're subtracting from has to be larger than the numerator of the other fraction.
But how?
You figured out. It's simple. Bye.
Simple for him. Yeah.
He said that the numerator of the fraction of the larger mixed number had to be made larger than the other numerator.
What if... I got it. What if we add 4/4 to 1/4? And that equals 5/4. And 5/4 is larger than 3/4.
So we can subtract.
So now we have a numerator large enough to subtract 3 from.
Why don't we rewrite the problem since we have a different fraction to work with?
Yeah, that 4/4 had to come from 6, which makes the renamed number 5 and 5/4.
I think we're getting close.
Yeah, instead of 6 1/4, we get 5 and 5/4.
And we can do the subtraction.
And we get the right answer!
We won! We won!
Wait a minute, we still have another problem in the bonus question to answer.
Oh, we're halfway there. $50, here I come.
Hey, that's half for you and half for me, remember?
Not a fraction less.
MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation.
This program was produced by the Illinois State Board of Education under the supervision of the Agency for Instructional Technology.